Hi, my name is Graydon Cortez, and this is Lab 5, Choose My Own Adventure, Projectile Motion. So to begin with, the purpose of this lab is to observe the motion and speed of an object thrown into the air to capture projectile motion. Hi, my name is Graydon Cortez, and this is Lab 5, Choose My Own Adventure, Projectile Motion. To begin with, the purpose of this lab is to observe the motion and speed of an object thrown into the air to capture its projectile motion, using Newton's second law of the momentum principle. Some important equations relating to Newton's second law are the velocity update formula, Vf equals Vi plus F net over m times delta t, the momentum update formula, P2 equals P1 plus F net times delta t, and the position update formula, Xf equals Xi plus Vx times delta t. For the main results of this lab, an object moving projectile motion will have a velocity of 0 at its highest point, and its y velocity will change throughout its motion due to the force of gravity. This will be proven through a video demonstration as well as a computational model using code. The model's assumptions and physics principles mentioned are used to prove that the momentum principle holds true and that it can be recreated in different settings, meaning F net equals delta P over delta T. So the initial conditions where the system was a Pringles can, the surroundings was everything else. At t equals 0, the initial position of the Pringles can was 0, 0, 0 meters. The initial velocity was 3.73, 2.42, 0 meters per second. The mass of the object is 0.4 kilograms. Gravity is 9.8 meters per second squared. And theta of motion is 45.7 degrees. So for the experiment, I tossed the Pringles can to the air and recorded its motion. And to the right are the results of the video experiment through analysis within the tracker software and a visual of the movement of the Pringles can. For the coding, I took the initial velocity and momentum and position found with the experiment step and created a computational model via the following steps. I divided the total time into smaller time steps and in a while loop, computed the net force, which stayed the same as 0, negative mg, 0 due to gravity. I updated the momentum using the momentum update formula, which incorporated gravity. I updated the position using the position update formula, and I updated the time, which is t plus delta t. And on the right are the results of the coding via GlowScript and the most important pieces of code, as well as a visual showing the ball's projectile motion in 3D. So for comparison of results, similarities between them are the data and model predictions have relatively same y position over the same amount of time. Thus, this proves that the constant force of gravity changed the y velocity over the time period at constant rate, as shown to the right as well. Difference are the computational model is coded to replicate a perfect projectile motion, and thus has a smoother curve of motion than the real-world model. Thus, this indicates that the data was not observed in perfect conditions. And as you can see to the right are the y position meters versus time in second graphs from the coding on top and the experiment on bottom. Some possible sources of error are the way the Pringles can was tossed into the air could have affected its projectile motion via its velocity and the force produced by my hand. The coding does not account for forces such as drag that affect the motion of an object while it is in the air. And the video and tracker has the top of it cut out due to video limitations and could potentially have affected the observations of the motion and its position at certain time intervals. Some concluding remarks are the x velocity of the Pringles can remain the same throughout its motion in both the observations and the coding models. The coding model graph is shown to the right, proving that the x velocity did not change throughout the time. Also, the y velocity of the Pringles can decreased at a constant rate due to the constant force of gravity acting on it. Furthermore, as the main results of this lab, the projectile motion's peak, the y velocity is equal to 0. And to the right is a graph that proves this result, showing that at around 0.4 seconds, the y velocity became 0, which is its height. And thus, the highest point of the Pringles can projectile is 0.911 meters. Thank you for listening.